All right, so welcome back, everyone. As promised, this is a recording for the extra exercise that we didn't have a chance to finish during the tutorial. So it's the last exercise of tutorial 3, just before the extra exercise section. Okay, so like the previous exercises, this one is giving you a language L and asking you to show that the language L is regular. So again, just as a reminder, to show that L is regular, we've just seen a first way of doing so, which is essentially creating or constructing a DFA M such that the language accepted by M is equal to L. So that's what I'm going to do here. That's the approach I'm going to have, is I'm going to try to create a DFA such that the language accepted by this DFA is L. Okay, so first of all, what is this language? Well, if we look at the language L, it looks like the set of all strings over the set or over the language AB star. So your universe is the set of all languages, the set of all strings, sorry, over AB. And the strings that you want in particular are the strings W, such that the number of A's in W minus the number of B's in W mod 3 is equal to 2. Okay, so just as a reminder of how Modulo works, because I'm sure we know how Modulo works for 2, but maybe some of you might have forgotten how it works for sort of larger numbers. So that's why I've put in this definition here, which is actually courtesy of Wikipedia. So imagine you have a number A here that you're dividing by D. Okay, so imagine you have, for example, here, the number 17, which you're dividing by 6. Okay, and you want to know what 17 modulo 6 is. Okay, so how do you do that? Well, the definition of the remainder of the modulo is that it's the number R such that the quotient times the divisor plus the modulo equals to your number A. So if we take 17 and we divide it by 6, so I'm doing the French way of dividing, then you could say that you have 2 times, so I just realized that I actually made a mistake in my example. You have 2 times 6 that fits into 17, so that's 12, and your remainder is 5. Okay, so your remainder is 5 because if you take your divisor and you divide your number 17 by your divisor, then your quotient is going to be 2, and your remainder is going to be 5. Okay, so this is the remainder, and so 17 mod 6 is equal to 5. All right, so, and the same idea applies if the number is negative. So let's say I have minus 5, and I'm dividing it by, let's say 2. Okay, so the number of times that you can fit this 2 into minus 5 is going to be a negative number. It's going to be minus 3. So this is minus 6. And your remainder is going to be plus 1. So notice here, the remainder is always positive. So that's why minus 5 mod 2 is going to equal 1. Okay? So that's just a review on the modulo notation. Now, how does this apply to our exercise? Well, here I've listed a couple of combinations of the number of A's and the number of B's. So for instance, I have, for example, 0 A's and 2 B's. So in terms of strings, that would look like BB. Or I also have 2 A's and 1 B. So that could look like A, B, A. And then I've done the kind of standard subtraction operation. So 0 minus 0, 0, and so on, minus 1, minus 2. Okay. And then I've, for the last column, applied the modulo. Okay. So from this kind of example here, you can actually kind of see that it's clear that 1 mod 3 is 1, and 2 mod 3 is 2. But minus 1 mod 3 is also going to be 2, because minus 1 is equal to minus 1 times 3 plus 2. Okay, and you can say the same thing about minus 2 mod 3. That's going to equal 1. Okay, so so that's about, so maybe just in case it's not clear, you have minus 2 and you have 3, okay, and you're also multiplying that by minus 1, and you're adding 1. So this is your remainder. Okay, so far it's not really any 335, it's just 232. So this is where the 335 happens. So just like in the even odd case, we can see that there are 3 possible cases here, right? Because it's mod 3. So if you have any number x mod 3, okay, then this can be one of 3 numbers, 0, 1, and 2. And so that's how I'm going to label my states. I'm going to have my state NA minus NB mod 3 equals to 0. I have NA minus NB mod 3 equals to 1. And I have NA minus NB mod 3 equals to 2. So then, how do I determine where my initial state is? Remember, for your initial state in these types of examples, just use lambda, okay? Lambda has, so if you're starting at lambda, which state are you going to start at? Well, lambda has 0 A's and 0 B's. So 0 minus 0 is 0. 0 mod 3 is also 0. So your initial state is going to be here. Okay? So now, how do I think of transitions? Well, let's think of an example. Suppose that you initially start with 0 A's and 0 B's. Okay? Then suppose you read an A. If you read an A, then what's going to happen is you're going to go from this to this, right? You're going to have 1A and 0 B's. So if you look at the modulo 3, then you're going to go from this state to this state, meaning that in this kind of DFA, if you read an A and you start at NA minus NB modulo 3 equals to 0, then reading an A, so in other words, adding an A, will lead you to NA minus NB modulo 3 equals to 1. And that makes sense because you're starting at 0 minus 0, then you're adding a 1 minus 0, and then that's equal to 1. Mod 3 is equal to 1. Okay, so that's the reasoning there. Okay, so now imagine you have 1 NA and you have 0, you have 1 A and 0 B. So in other words, you're in this state, right? In this state, okay? Whoops, sorry, not that state. In this state. Sorry, the table isn't very perfect. So now, what happens if you jump from here to here? That is, suppose you have an A. So suppose you have an A, but now you also have a B in your string. So let's put the string over here so it's really obvious that we're looking at this string, okay? Then what happens is your number of A's stays 1, but your number of B's becomes 1 as well, okay? So that means that you move to this state, right? And in that state, 1 minus 1 is 0, mod 3 is 0. So you move to this state. So you go here, meaning that in your DFA, you're going to go back with B here. So now, again, let's try another possibility. Let's say you add a B. So in this case, now you have 1 A and 2 B's. So you're going to jump from here to here, actually. Okay. So then you have 1 minus 2. 1 minus 2 is minus 1. Mod 3 is 2. And so you're going to jump from NA minus NB mod 3 equals to 0 to NA minus NB mod 3 equals to 2. Okay. And I feel like at this point, it might seem a bit easier. It might seem a little easier to grasp what's going on. If I'm in this state here and I read a B, I'm just going to reduce my modulo by 1. So quote unquote, because that's not really how modulos work. But in terms of states, that means that I'm going to transition to this state. If I'm actually in this state and I read an A, then I'm going to add an A to my number of A's. So I'm going to add plus 1. And so then I'm going to go to mod 2. Okay. And then, so this is for B, this is for A. And then finally, if I'm here, I'm in this state and I read another A, then I just reset the clock and I go back to 0. So NA minus NB mod 3 equals to 0. So does this work? Let's use a more complicated example. A, B, A, B. So I have, my number of A's is 3. My number of B's is 4. So 3 minus 4 mod 3 is minus 1. Mod 3 is 2 mod 3. So in theory, I should end up in this state. So let's see what happens. So I start here. I read an A. So I go here. I read a B. So I go back here. I read a B. So I go here. I read an A. So I go back here. I read another B. So I go back here. I read an A. So I go back here. And I read a final B. And I'm back in NA minus NB mod 3 equals to 2. Good, so it works. So now all that's left is to write in that final state. And here it looks like we want mod 3 equals to 2. And so that's what we're going to do. Whoops. Whoops. Okay. We're just going to make this state here a final state. And that gives you, well, it looks a bit different, but trust me, it's the same. That gives you the DFA that accepts this language. Okay, so that's, yeah, so that's all I wanted to say about this exercise. Hopefully this way of explaining it was clear. If not, you can always send me or Tianyi an email. Thanks and see you next time.